welcome you all. The topic is scope of AIML in IoT world today. So let's talk about artificial intelligence. A plant grows towards light source. Can you term it as intelligence? And whenever someone sees a danger, he runs away from it. Can we call this as intelligence? And although we can term them as intelligence, I am not really interested in these intelligence. This is kind of a basic living instinct where you want to save your life, be it going towards light or be it running away from dangers. We are currently not interested in this kind of intelligence. We are looking for something which is similar to human brain, and it's by the agents which we are created. It doesn't come naturally. And this is what we are trying to call as artificial intelligence. So AI is a technique that enables machines to behave like humans. So that's the kind of things we are trying to create, and that's the kind of thing we are talking about today. Okay, so let's talk about intelligent car. Today, when you want to go from position A to position B, you go to your mobile app, hire a Uber or Ola, the car comes in, you sit in the passenger seat, and the driver takes you to wherever you want to. Now, think about a car which has only a passenger seat. There is no driver, you don't know. You are sitting in the passenger seat, and it will come to your location to pick you up. You sit down, and it takes you. That's the kind of intelligence we're talking about, where we are not able to make sure that the driver is a machine or driver is a human driver. So a car can have several sensors and actuators to drive the car, to find out the path, to traverse from your source to a destination. And you need not worry about it. Everything looks like as if you're having a chauffeur who is taking you to the destination. Or you're playing a game against some opponent and you're smart enough, and that opponent you are not able to understand is a human or a non-human, because you are sometimes able to beat him, or he is able to beat you sometimes, or maybe most of the time. So that's the kind of things we're talking about as artificially intelligent. What it builds on? It builds on mathematics, it builds on computer science knowledge, it builds on the neurosciences, the psychology, sociology, the philosophy, how humans think, and the biology as well. So all these things feed to the knowledge which the artificial intelligence uses to create agents that are smart, that are intelligent. That's what we call artificial intelligence. And what is good at? It is good at doing things which are repetitive. So it automates them. The incredible accuracy means if it learns to do something very good, it will continuously do it, which sometimes is much higher than the human accuracy. That's the kind of importance it gets. And the other thing is, as a person, by doing things again and again, he or she adapts and learns it more and more depth. That's the kind of agents we are trying to create, who can adaptively improve their own intelligence level. And ultimately, they should be able to provide much more deeper understanding and information, so they can be used for doing things which we don't understand. For example, we have so many sensors in our body, in our eyes and ears. How do they work? How we see is something which is internal to our genes and our body. We don't really know them. And such kind of things also we should be able to solve using the artificial intelligence agents. There are various kinds of things that can be done here. Now, moving on to machine learning. You must all have written programs. So programs are generally, you know the input, you know the output, and program in a way that this should give me that result. It processes in a fixed manner to give that output. Whereas a machine learning program is something we want that for certain types of input, this should be types of output. So it should be able to maybe classify something or do something which you are giving examples of. It's a kind of artificial intelligence. So it gives the capability of this data to the machines, which can make decisions based on this data. So the output is another model which comes out. On this kind of inputs, it provides that kind of output. So its output is actually a set of scenarios which should behave in certain way. So let's take an example. You must already have in Gmail or in any other email some filters which says, okay, this is spam or this is not a spam. How it is trains? It is using the data to train itself. That's kind of programming which we don't do explicitly, but we train it using the input data to give that kind of output, which is a program once again. So here the output is a program rather than a single output in the normal program. That's the difference between normal programming and the machine learning programming. So what are different types of machine learning? We have supervised learning. Think of it as a school where the teacher is telling you by examples, one by one, on the given problem. Okay, this is solution. This is the problem. This is the solution. And the students are learning how this is working. And at the end of the training period, at the end of their school, they come to know how to solve these kind of problems. They become good in solving these kind of problems. So that's the kind of supervised learning that they have been trained on. And so when we have a supervisor, that's supervised learning, which is training you by example. You have unsupervised learning. Think of it as, yes, a self-learning. For example, you go to a park with your child or your small kid is with you. Both of you see the same thing and also the input is same, but the output can be different. Your children or your small companion can see a park to play. You can see this is place you can sit in peace and relax. So the final outcome is something which is based on this input, but it is something which you come up on your own. That is unsupervised learning. So you don't, you're not giving an example on when to see this. This is the output. You devise your own output here. What you want from this set of input. That's the unsupervised learning. Similarly, we have a reinforcement learning where you are giving some feedback. Okay, you are given a task to do. You have done the task well, or you have not done it well. That feedback is given to you, and over a period of time, you learn to do a task well. There is a reinforcement given every time you have done it well, or there is a feedback given you have not done it well. So that's the reinforcement learning. All these three are kinds of the machine learning. How supervised, unsupervised learning is different from the reinforcement learning. Unsupervised learning is something which the conclusion is something to be derived on your own. No one is going to tell you it is right or wrong. You have some conclusion. But in the reinforcement learning, there is a feedback given at the end of every trial, whether you are on the right path or you are not. So that is the difference. There's a feedback kind of thing in the reinforcement learning, which is not there in the unsupervised learning. So that's how they are different. Okay, let's move forward and talk about what is IoT. And let me talk about internet first. Internet is something which is a medium which helps us to communicate to each other, right? It's an internet of people. You come talk to me, I am talking to you. And what are we talking about? We are talking about what we have perceived, we have sensed, we have sensors, we have eyes, we have ears. So that's what we are talking about. Whatever we have sensed, we are talking about it. Now, think about when things around us, they start talking to each other. What they can talk about is whatever they sense. For example, there is temperature sensor. If it gets the capability to talk to someone about what temperature it is perceiving, and maybe there is a mobile app, it is talking to my mobile that, okay, this is the current temperature in your room. That's the talking. It is happening between my mobile and my temperature sensor. So when things are talking to each other about whatever knowledge they have, that's the Internet of Things. So it's in words we put connecting everyday things with electronics and software and putting them on internet. That means they should have this capacity to interchange data, to express themselves, to listen what someone is saying. Then it becomes Internet of Things. Just like you are talking and you are listening, I'm talking. It's based on Internet of People, you and me. When things are involved, it becomes Internet of Things. It enables things to collect the data and exchange that data, take decisions based on them. the benefits, the money benefits. We can improve our resource utilization and reduce the human effort, save human time, and lots of things we can do. Improved security is one of them. And all these things come into the purview of IoT and use this data intelligently. That means the AI part, whatever data is coming from these devices, that can give a huge benefit to our life, human values. In the international IoT market, currently it is estimated more than worth $1.7 trillion. Every second, 127 new IoT devices are being connected to internet. And going by some research, the growth rate is going to be at least 10% in days to come. I hope it's going to improve much, much faster. And here are some of the current successes. For example, predictive maintenance. Now, when you are driving a car, you go for periodic maintenance. Every 6 months, you go to send it for maintenance. Or you send it for maintenance whenever something goes wrong. So either we do it on a time basis or we do it on the failure basis. But using the sensors, if we have the right sensor throughout my car, we can improve it and do it minimal and in time so that I don't face any troubles. This is already being done in industry. Then you have assets, you have machines, and you have sensors in them. You can use them to improve the performance. Once you have them, you analyze those sensor data right there in your premises to improve the performance. You can also do some condition-based monitoring. So you already know on such and such conditions, there is something which can go wrong. It should take a decision or it should raise an alert. So those kind of things are very simple. You already know, use that sensor data and raise the alert. The process efficiency. The overall process, the operating cost for machines, the overall industry can be improved using the data from sensors. And the key performance indicators of any industry can be improved a lot using those sensors data. So all these things what I just told is currently being used by many industries around the world using the sensor data. And they're already in place. Now, going ahead, why I'm so optimistic about it? The reason is, if you read the sentence, in the current oil rig industry, there's less than 1% data which is currently being used to make decisions. So think about, at this moment, it's less than 1%. How much data is being generated? This kind of data. In mining, 1 petabyte of data is generated every day. Jet engines, 480 terabytes. So just think about the huge amount of data. And this is everyday data. It is not about over a time. It's every day. So that's the kind of data. So that also brings up the challenges. What are challenges? First is all these devices we are talking about have very low CPU capabilities. This amount of sensors is huge. And they're generating data at a huge frequency, very high frequency. Every device manufacturer has its own standards they follow. These devices are very low memory devices. And if you put all this data on the network today, think of the condition. Your network is not going to move, much less the traffic you see on the road. Plus the security of data. When you want to make it available online, it's going to be a security issue or some legal issues. So there are lots of challenges here. And there are many more. These are some of the major ones. So there's kind of sensors you already know about. Accelerator sensor, proximity sensor, gas sensor, temperature sensor, and whatnot. They're just some sample of sensors we have seen around us already. Or if not, you can see around easily. So now let's go about the future prospects of AIML in IoT. So we already said, okay, there are lots of sensors used by industry. If you can use those sensor data intelligently, it can be a huge thing for industry, huge savings. Similarly for healthcare, smart cities. Environment is a big problem even right now. So we have data, can we use it intelligently? So let's consider it about human beings. We sense throughout our day. We listen, we see, we eat, we smell, we feel. But do we put all the things that we are seeing or listening on the internet? No, we don't. What do we put? We have an intelligent brain which collects all this and comes up with something which is small and worth sharing, which is important to others, which is useful for others. and shares only those things. So here is the AI and ML part. IoT is something, okay, the sensors we have. AI and ML is the brain we have. So we have the bodies around in the world. What we need to get is this brain to churn this data and come up with something which is useful, which is important, and share that. And that's where this thing is going to be huge. We can also use it in security or even emotional analysis, home automation, automation. These are some very small fields, I should say. But to start with, these are one of the major fields for AI and ML into IoT. Now we'll see who all are stakeholders. So all the device manufacturers, all the network providers, then you have to write software for working, the cloud services, so that when this data is shared, they can be available and sent to location. And most of all this should be combined and packaged into a single product which someone can use easily. So the service providers, which will give you a single interface for everything to be done easily. So all these are stakeholders in this market. And what do you need to know? Okay, you should know about the sensors. You should know about programming those devices. The devices. Then you should know about the network, how to connect to network to share data, how to store it in the cloud programming part. The UI has to be simple enough so that anyone and everyone should be able to use it. It should not be limited by the knowledge of the person who wants to use this. As I said, it's the AI and ML programming which is going to play a huge role, because that's where all these things can be really made useful. And to get all these things working, you need to have the data structures and algorithms, as well as the optimization part, because we are trying to work something with low CPU, low memory, low energy kind of things. So optimization is absolutely must. And let me come back to now something of a more concrete, which you can all see or relate to very easily. So they all have something in common: smart city, smart home applications, smart transportation. And I think you're all aware of all these things. For example, let's talk about the smart city. Hear this word smart city, what comes to your mind? The water supply should be efficient. Something which is a scarce resource should be used efficiently. Waste management is a big area. You see wherever you go in city, or you see huge piles of waste, or even around the cities. Now those things can we do using some better management. Smart logistics centers. You need to move goods from one place to another. What is the best way to move it? A smart city should have all these things. So these are the kind of things which our kind of should have. Okay, city car sharing or the infrastructure monitoring. There are roads, there are lights, there are many other resources, infrastructure resources around the city, which we should make sure they are in good conditions and they should be monitored regularly. Smart grid, smart street lights, smart community, environment. Today, pollution is one of the biggest issues in the big cities. We need to make cities which are much better. And that's where people are working. For example, Sigfox. These are some of the companies. M2O City, they provide already smart meters which are being used to improve the energy utilization. From Veolia, we have comprehensive range of digital solution for local governance. The 𝐀𝐛𝐨𝐮𝐭 is used by several cities in USA and Europe to improve the infrastructure and the connectivity in the cities. IETF is providing us with the high quality documents on how it should be produced. Even ZigBee Alliance is something which is of getting standards, because as of now, there is no standard way to create something. So we need to have those standards. These things are very useful in getting something which can be used at a large scale. Coming back to smart home. When you think about smart home, home automation is the first thing which comes to mind. Remember air condition control. When should the air condition be turned on or off? We decide as of now. We go and switch it on or switch it off. But can it be done by some agent, which is an intelligent one, and it does it for me? Before I come home, my home should be have certain temperature. When I come home, my door should open, but when someone else comes, it should not open. Infrared sensor can be used to understand if I am in home or not in home, or something, a personal application, which personal assistants we already have sometimes. Telemedical care, something which I'm at home, I need some medical attention, there should be someone to assist me. How can I detect a smoke and automatically take some action on it? Right now, parking is a big problem in cities. Can we have something which is smart parking? The car itself knows where to park, or it gives me a hint. So these are the kind of smart home applications. Then they are not only these, there are many other. We need to have autonomous appliances. We already have Google Home and Alexa to share things from internet. We don't need to type them out most of the time these days. But there can be many more things that can be done. And these are some of the companies. Philips, you already know. Bosch, you already know, I guess, most of them. Cisco, you'll be understanding in the network system provider, I should say. Digitum, Dash Telecom, Itron, Sierra Wireless. These are some of the companies. And remember, all these companies, even the ones we showed previous, are not only restricted to smart home only. You can use the applications even in smart city or in smart transport or anywhere. These are the platforms that can be used anywhere you find a fit for. Moving on to smart transportation. In our body, we have millions of cells. All these cells need nutrition. All these cells need oxygen. And all these cells throw out carbon dioxide as well as other toxins. We also have a system to take this nutrition from our intestines and reach those cells. Take the oxygen from our lungs and put into all those cells. And take these toxins and put into the kidneys. Take those carbon dioxide and send back to lungs. We have a very good transport mechanism, which we call blood, which takes all these things and moves in such a way that our body functions without any disruption. There is no disruption here. Can the AI and ML use the big data we can have? We know in any city who lives, who stays, where he goes for work, where he gets his things from, what are his daily activities, how much are the traffic on the way. Can we get all this big data, churn them, and come up with something very smartly so that all this traffic becomes smart? Just a thought. But with the kind of things we have today, I believe this kind of solution should come up sometime. If not 2 years or 5 years, maybe 10 years. But we can be a part of it. We can see it, that it starts working much, much better. So that's the kind of thing smart transportation I'm thinking about. It can be not only limited to real-time traffic monitoring, traffic control, or navigation, but a much more comprehensive thing. Here are some companies which are working in the area of smart transport, smart mobility. You already know about Uber and Lyft. We have CTCC, which is an NPO, and it's getting kind of standards kind of thing. ETSI is also a European standard organization, but the standards are also used globally. 1M2M develops technical specifications, and GMV is providing some intelligent integrated solutions for transport management. So these are some of the companies which are into the smart transportation systems. Example of industry based on IoT product in current date. I am working for a company called Foghorn, and we have a product which is actually a platform itself, which are used by big industries. It's still not in India because we have most of our clients outside India. So it's kind of, we provide them the solution which they install on their simple devices, and they can make decisions out of it. The decisions like, there is an area where you have to always wear helmet, and some person reaches there without helmet. The manager should get to know that such and such person is in this area, in this location, and he is not wearing helmet. Or if there is a fire somewhere, how big or how small it is, it should be along with the position, should be told to someone who's sitting in the office. So those kind of things we are already having as our products right now. How can we club ML and IoT together? IoT is something like the small devices, and ML is something like brain for them. Once we have the data from these devices, and we have an ML agent which works on this data to provide a conclusion or a alert or a suggestion based on this input data, or take some action. So this is how it is going to be combined. Think about it as inside my home. I wear a fitness watch. Think of it as a heart rate monitor. It continuously knows my heart rate. And one day in the morning, it vibrates so heavily because it has detected something is wrong in my heart rate. It informs the doctor, ambulance is on my way, and as soon as I wake up, I am whisked away into the hospital saying something is wrong. By the time it reaches the hospital, the doctor is already there, and he knows my history, he knows my problem, and I am operated to get rid of a imminent heart attack. Think of it that kind of thing. So it is the fitness smartwatch helped me avoid a heart attack. It knew based on its ML agent that this heart rate is not normal. There's something abnormal. It figured out what's abnormal. It informed the doctor. It called the ambulance automatically. So that's where the ML and IoT come together. What we tell passive mode in IoT. When we say passive mode, it's the data collection. And it is active mode. That means it's collecting the data, analyzing it, and taking some other action onto it. So passive mode is collecting data right now. After this coronavirus attack, what would be the impact of AIML plan? As this would be big economy loss for the world, still will be there for a month. Actually, it's going to make things much faster. Think about it. Humans are required in offices today to take care of things. Now, if things can take care of themselves, we can work from home as well. So more and more usage of AI and ML as well as IoT is sure for the future. How difficult or easy is it for a 10+ years experienced person in other field to get job in AI ML just by a course? I think just by a course, it would need some projects. The thing is, in today's world, your experience does count, but experience is not only what you do in office. Experience is also something which you do out of office. If you can work with some mentor, take some project, do it, that always counts. Because only when you find some issues and get way through it to reach your goals is something which adds to your value. And that's where it's acknowledged and it can be used into your resume as well. Okay, I think I'll stop here now. So thank you all.